Hi guys, this is a continuation of our previous video where we solved the first 8 problems. Now we will continue to solve the next 4 problems in the exercise. So here we are given if D is the midpoint of the side BC in a triangle ABC. So let's define this as our triangle A, B and C, and D is the midpoint of BC. Prove that AB plus AC is equal to 2AD. So this is what we need to prove. So to prove AB plus AC is equal to 2AD. Okay, so we can define the AB vector in this direction, the vector AC in this direction, and the vector AD in this direction. So let's define 2 more vectors, DB and DC. So AB vector can be defined as AD plus DB. So AD plus DB vector. This is our 1. And we can define AC vector. AC vector is equal to AD plus DC. AD plus DC. So call this 2. If you add 1 and 2, you will get AB vector plus AC vector is equal to AD vector plus DB vector plus AD vector plus DC vector. So you can add these 2 terms and say 2 times AD vector plus DB vector plus DC vector. Further, our DB vector is equal in length with DC but in opposite direction. So we can say DB is equal to minus DC. Equal to minus DC. So we can say from this what we have here, 2AD plus DB vector minus DB vector. So this will become 0. You will be left with 2AD vector. So you can see that our LHS is equal to RHS. Hence the proof. Okay, in the next problem, G is the centroid of a triangle ABC. So let's mark this triangle as A, B and C, and G is the centroid. So which means let's mark this point as G, and when we say centroid, it is the point at which all the medians meet. So let's define our medians as AD, BE and CF. So D is the midpoint of BC, E is the midpoint of AC, F is the midpoint of AB. Therefore, AD, BE and CF will be medians, and the medians will meet at the same point G. Okay, or intersect at the same point G. Now we can say that further the ratio at which, if this is the centroid, then the ratio at which it divides this median will be 2:1. So we can say that the ratio of AG and GD can be written as 2:1. Okay, so if this is 2:1, then our vector GA, let's define this vector GA vector GA, which is in this direction, will be equal to 2/3, because GA is 2/3 of the whole length AD. So we can call this as 2/3 of DA vector, right? So if we change the direction of DA to AD, this will become minus 2/3 of AD vector. So that's our GA. Let's mark this as our first thing. Similarly, we can show our GB as, which is GB, to be 2/3 or minus 2/3, our GB to be minus 2/3 of BE vector. This is number 2, and we can also show that our GC is equal to GC vector. Okay, let's draw the direction. GC vector will be 2/3 of CF vector, or minus 2/3 of CF vector. Okay, so if we add the 3 together, GA vector plus GB vector plus GC vector, and substituting the values, minus 2/3 AD, we can put them within bracket because minus 2/3 is common for all, plus BE vector plus CF vector. Okay, and we can further notice that our AD vector is AB vector plus half of BC vector. Okay, I can say AD vector, which is this one here, will be AB plus BD, and BD is half of BC. So I can write this as AB vector plus half of BC. So substituting that value here, we get minus 2/3 AB vector plus half of BC vector. Similarly, BE can be written as BC vector plus half of CA vector. BC vector plus half of CA vector, and our CF can be written as CA vector plus half of AB vector. CF can be written as CA plus half of AB. Okay. Now, adding them all together, you have a half BC here, and you have a BC here. So we can write that as, let's start with AB. AB plus half of AB can be written as 3/2 AB vector plus 3/2 BC vector, half of BC plus BC, half of CA plus CA can be written as 3/2 CA vector, and that can be written as minus 2/3 into 3/2 into AB vector plus BC vector plus CA vector. Now, AB vector plus BC vector plus CA vector by the triangle law will be 0. So your answer will be, and you can even simplify this if you want, but however, this is going to be minus 1 into 0 So your answer is 0 vector. So hence the proof LHS is equal to RHS. Our same problem can be used in a different method. We can call this as method 2. But for this method, let's consider a point O of origin and let's define A, B, C as our triangle. So when I say OA, I'm referring to an angle A vector where vector A is equal to OA. So similarly, I can define for B and C, and this center point is our G. And these points, we can define them as D, E, F. And so AD, TF and BE are the medians and they intersect at G. Alright, so whenever we are referring to OA, OB, so we will be referring to the point of origin O. Okay. Now, we know that if this is the concurrent, this is the centroid, then we have our OG vector to be vector A plus vector B plus vector C divided by 3 if OA is equal to vector A, OB is equal to vector B, and OC is equal to vector C. Now, let's look at our vector GA plus GB plus GC vector. Okay. Now, we can define the vector GA as minus OG plus OA. Minus OG plus OA. Or you can say A vector minus OG vector. So, our GA can be written as A vector minus OG vector. Similarly, our GB can be written as vector GB. This is vector GA. GB can be written as minus OG plus OB. So, which is a plus B vector minus OG vector. Plus, we can also define our GC, this vector GC, as minus OG plus C vector. So it's C vector minus OG vector. I hope that was clear. So further simplifying this, we get vector A plus vector B plus vector C minus 3 times of OG vector. Now further substituting the value of OG vector from here. So this we can say as vector A plus B plus C minus 3 times vector A plus B plus C over 3. 3 and 3 will become cancelled. You can see that our A vector plus B vector plus C vector minus A vector plus B vector C vector will be 0 vector. So LHS is equal to RHS. Hence the proof. Okay, now next problem. Let A, B, C be the vertices of a triangle. So let's mark A, B, C to be the vertices of a triangle. D, F are the midpoints of the sides BC, CA and AB. So we start from BC, D, E and F are the midpoints. So vector AD plus vector BE plus vector CF is equal to 0 is what we have to prove. Okay, so let's say to prove vector AD plus vector BE plus vector CF is equal to 0 vector. Okay, let's define vector AD first. We can define our vector AD as vector AB plus vector BD. Okay, so vector AD can be defined as vector AB plus vector BD. And we know that vector BD is half of vector BC because D is the midpoint. So we can further write this as AB plus half of BC vector. Similarly, let's write our BE to be, and let's mark this as 1, to be BE vector will be equal to BC vector plus CE vector. So it's BC vector plus CE vector, and we can further write CE as half of CA plus half of CA vector. Let's mark this as 2. And our CF vector can be written as CF vector can be written as CA plus AF, which is half of AB. So I can going to write this as CA vector plus half of AB vector. So this is my 3. Now adding 1 plus 2 plus 3, you will get your left hand side as AD vector plus BE vector plus CF vector is equal to, let's put the values, AB vector plus half of BC vector plus BC vector plus half of CA vector plus CA vector plus half of AB vector. Okay, further simplifying, AB, 1 AB and half AB will become 3 by 2 AB vector. Similarly, 3 by 2 BC vector plus 3 by 2 CA vector. So 3 by 2 is common, so if we take it out, 3 by 2 into AB vector plus BC vector plus CA vector. We know that AB plus BC plus CA will be 0. So that's equal to 3 by 2 into 0 vector. So that will be 0 vector. So you can say this as 0 vector. So our LHS is equal to RHS. So you can say hence the proof. Okay, so this is the last problem in this video. I hope you're finding it easy. I think vector algebra is one of the most easiest topics, and you can score very good marks if you keep practicing it. So if ABCD is a quadrilateral and E and F are the midpoints of AC and BD, so we're going to define the quadrilateral A, B, C and D, and our point E is the midpoint of AC. So AC's midpoint will be E, and F is the midpoint of BD. Okay, so I'm going to mark these 2 points as E and F. Okay, then we need to prove that AB plus AD plus CB plus CD is equal to 4 times EF. Okay, so let's start defining. So we need to prove first AB vector plus AD vector plus CB vector plus CD vector is equal to 4 times EF vector. Okay, So let's start by defining our AB vector, which is here first. Yeah. So AB vector can be written as, the vector AB can be written as AE plus EF plus FB. Yep. So we can write this as AE plus EF plus FB. So let this be number 1. Similarly, we can write our AD vector as vector AD as AE vector plus EF vector plus FD vector. Okay, so this is AE vector plus EF vector plus FD vector. Next, we can do CB vector as CE vector, CB as CE vector plus EF vector plus FB vector. Okay, so CE plus EF plus FB. CE plus EF plus FB vector. This is number 3. Then the last, which is CD vector, can be written as CD can be written as our CE vector plus EF vector plus FD vector. So CE vector plus EF vector plus FD vector. So this is number 4. So if we add all the 4 of them together, we will get AB vector plus AD vector plus CB vector plus CD vector is equal to, you have 2 AEs, so 2 AE vector, then you have, so let's write these 2, you have 4 EF, so plus 4 EF vector, then you have 2 CEs plus 2 CE vector plus you have 2 FBs plus 2 FB vector plus 2 FD vectors. Okay, so further simplifying this, we can write this as 4 EF vector. I'm bringing the 4 EF here. Then you can write this as 2 times of our terms AE plus CE. AE vector plus CE vector plus 2 times of the remaining terms, which is FB vector plus FD vector. Now you can notice that our AE plus CE, AE plus CE, since AE is the midpoint of AC and AE will be equal in length or in magnitude to EC, but in the opposite direction. So if you add them together, it will become 0. So this will become 0. So 4 times of EF vector plus 2 into 0 plus similarly FD, FB plus FD. Since F is the midpoint and they are in the opposite direction, again this will be 0. 2 times of 0. So your answer will be 4 EF vector. So LHS is equal to RHS. Hence the proof. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.